In this video, we will learn how to find out the equilibrium basket given the different types of linear utility functions. The question is, suppose utility function of a consumer takes one of the following forms. We have three different kinds of utility function, that is u is equal to 50x plus 20y. U denotes utility, x and y are the two goods. In the second case, utility is equal to 20x plus 50y, and in the third scenario, u is equal to 80x plus 40y. Here income of the consumer is 10,000, price of good x is 50, price of good y is 20. Determine the equilibrium in each case using diagram and comment on the nature of the solutions. By equilibrium, we need to find out the equilibrium basket. Okay, I forgot to write it here. Equilibrium basket. Okay, so let's take case first. We are being given this is our utility function and we need to construct the budget constraint here. Okay, so what will consumer do in each of the case? He wants to maximize the utility derived from the consumption of two goods. We have 50x plus 20y such that price of good x times units of good x plus price of good y times units of good y should be equal to the income of the consumer. Specifically, price of good x is 50, so can we write 50x plus 20y is equal to 10,000. And let us further rewrite it, dividing both sides by 10, which gives us 5x plus 2y is equal to 1,000. Okay, now let me draw the graph also to make the things more clear. So let us suppose I draw a simple graph. We have x good on the horizontal axis, y good on the vertical axis. Okay, so consumer wants to maximize his utility subject to the constraint that he is facing. Okay, let us draw this and we will draw the constraint and then we'll explain it. Okay, so what is the equilibrium condition or optimal condition for utility maximization? We know that at equilibrium what should happen? The marginal rate of substitution between good x and y should be equal to the ratio of the prices, that is price of good x upon price of y. This condition must hold or should hold. Okay, if this does not hold, okay, then what happens we will see. So what is MRS? We know that MRS is simply the marginal utility of good x upon the marginal utility of good y. Okay, price of good x upon price of y, price of x upon price of y. Let's compare these two. So marginal rate of marginal utility of good x means the partial derivative of this function with respect to x, that is the change in the utility due to the consumption of good x. Okay, so derivative of this function with respect to x was 1, so we are left with 50 divided by marginal utility of good y means the derivative of the second term, which is 1 here, so we are left with 20. And what is price of good x and price of good y? That is being given us as 50 upon 20. So here we also got 50 upon 20. So what happens here? So this 0 and 0 gets cancelled, this 0 and 0 gets cancelled. Now let me explain. What does this stand for? Price of x upon price of y. It denotes the slope of budget line, and this MRS denotes the slope of indifference curve. Now what happens in this case? In the first case, the slope of the indifference curve and slope of the budget line are equal. Okay, when the slope of what we call indifference curve and slope of budget line equal, and we know that our indifference curve is linear. Okay, so what will be our equilibrium basket? Let me draw the budget line first. Let us suppose this is our budget line. Okay, this is our budget line. Now the slope of the budget line and the slope of the indifference curve is same. That means one of the indifference curve can be this IC1, but this does not maximize utility. Okay, so another can be this one, let us say IC2. This will not also maximize utility. And last one if I draw it here, it will coincide with the budget line. So at this on this line, any point, any combination of good x and y actually maximizes the utility of the consumer. Why? Because the slopes are equal, that is slope of indifference curve and slope of budget line are same here. Then what will be the equilibrium basket in this case? We will get infinitely many solutions here. Okay, so since this is our utility function, now one of the optimal basket can be, so since 5x, let us solve it. So we have 5x is equal to 1000 minus 2y. Okay, let us say when we have, let us say when y is equal to 5, when y is equal to 5, let me repeat, since the slopes are equal, let us suppose this is slope of the indifference curve, this is slope of the budget line, they coincide with each other. So when we solve this, so when 5y is equal to 5, that means 5x is equal to 10, 1000 minus 2 into 5 is 10. So it will be 1000 minus 10, which is 990, dividing both sides by 5. So we get x is equal to 5 ones are 5, 5 nines are 45, 5 eights are 40. So one of the equilibrium basket will be, that is 198 units of good x and 5 units of good y. Okay, so let us suppose this is here 5, this is here 198. Okay, 198, this is one optimal consumption bundle. Similarly, so here we don't get the corner solution, we get interior solutions, or even we get the corner solution. If we solve y is equal to 0, so x will be equal to 1000 upon 5, so which is equal to 20. Okay, so another can be when y is equal to 10, so 5x is equal to 980, or x will be equal to 5 ones are 5, 5 nines are 45, 5 eights are 40. So another, how I am getting the same 990. So 5 ones are 5. So here it is 30. Okay, simple mathematics I am not able to do here. So we have 980 upon 5. So 5 ones are 5, actually so 5 nines are 45, 5 6 3, 5 6 are 30. So 196, sorry, another will be 196. So another combination can be 196 units of good x and 10 units of good y. Let us suppose this point. Okay, this is another optimal consumption bundle here. So here we have 198 and 5, and here we have 196 and 10. Okay, why does this happen? Because both the slopes of the utility function and the budget constraint or budget line are same here. That's why we are getting many solutions here. Okay, now let us come to the second utility function. Okay, again we want to maximize. In case of second, what we need to do, we again need to maximize u is equal to, so this time we have 20x plus 50y subject to the constraint. Constraint is same, that is 5x plus 2y, such that 5x plus 2y is equal to 1000. Okay, again let us draw the graph. Okay, so let me draw the graph here, a very simple graph. So good x on the horizontal axis, good y on the vertical axis. Now let's compare the slopes. So okay, so we have MRS. MRS between x and y should be equal to the ratio of the prices. Okay, so MRS is the partial derivative of this utility function with respect to x, so derivative of x is 1, so we are left with 20. Here we are left with 50. Price of x upon price of y, it is 50 upon 20, so it is 50 upon 20. So let us remove these zeros here. So what happens here, or let me use the color combination 5 upon 2. Now here you can see 5 upon 2 is greater than 2 upon 5. And what is 5 upon 2? It is the slope of the budget line. Slope of budget line. And here you can see slope of budget line greater than slope of indifference curve. Okay, so how do I show the slope of budget line? So this is our budget line. Let me draw it like this. Okay, this is our budget line. Now the slope of the indifference curve is flatter, so it is steeper because 5 upon 2 is 2.5. It is flatter comparatively to this. So let me draw one indifference curve. This will not optimize. Second can be this, third one can be this, fourth one can be this. So at a point where it intersects or it touches it, so let us say this is IC4. Okay, so IC4, at this point we are getting this touches the indifference curve. Here it intersects. Okay, you can see here. So where it touches this budget line, our utility will be maximized. So what happens at this point? At this point is we will consume x will be equal to rather 0 units of good x. Okay, because we are getting corner solution. If x is equal to 0 in this equation, then 2y is equal to 1000. So y is equal to 1000 upon 2, which is equal to 500. Okay, I hope I have done it correctly here. In the second, what happened? The slope of the budget line was steeper than the slope of the indifference curves. That is why we got the corner solution here. So what is the consumer will consume 0 units of good x and all units of good y. When x is equal to 0 in this equation, so 2y is equal to 1000, y is equal to 500. So our optimal solution will lie here. Optimal consumption basket, or rather magenta 500. Okay, so this will be the optimal bundle here. Now in the third case, okay, let us break down the third case also. Third case we have, we again want to maximize utility which is being given by the linear function 80x plus 40y, subject to the constraint that is 5x plus 2y is equal to 1 is 10 is 100,000. Okay, again comparing the MRS and the price ratio. So MRS will be equal to, let me write it here, MRS xy should be equal to price of x upon price of y. Okay, color combination की तेल लेने. MRS is simply the ratio of the marginal utilities of good x and y. So partially differentiating with respect to x gives us 5. Partially differentiating with respect to y gives us 2. And what is the ratio of 80 upon, sorry, I have, okay, 5 upon 2 coupled square. So 80 upon 40. So we have 80 divided by 40. Okay. And what is price ratio? That is 5 upon price of x upon 5 upon 2. So here we have 4 ones are, 4 twos are, here we have 2, here we have 2.5. Again, slope of budget line is greater than slope of the indifference curve. Slope of IC. Okay. So if I draw the indifference curve here, so we have x and y. Slope is 2.5, here it is 2, so it is steeper. That is, budget line is steeper, but indifference curve is flatter. And in this case, what will be our optimal bundle? That means when here x is equal to 0, x is equal to, consumer will consume 0 units or no units of good x and all units of good y. That means 5x is equal to 1 is 10 is 100,000 or x is equal to 0, so x is equal to this 5x is equal to 0, so 2y. Okay, so 2y is equal to 1000 or y is equal to 500. Okay, again consumer will consume at this point where x is equal to 0 and 500 good units, 500 units of good y. Okay, if it were the case that, let us suppose we have in place of 80, let me explain the third case because we are getting the same cases here. So let me explain in the fourth one here. Agar मैं जाए, yes, I have the space, so x and y. Let me just rewrite it. Okay, so let us suppose we have the fourth utility function, that is we want to maximize u is equal to, in place of 80, let us write 120x plus 40y. So such that budget line is same, 5x plus 2y is equal to 1000. So here MRS between x and y, and we compare it with price of x and price of y, that is price ratio. So MRS will be here 120 upon 40, okay, using this partial derivative baggage GS. So it is 120 divided by 40, so it comes out, and price ratio is 5 upon 2. Here it is 4, oh sorry, it is 3, and here it is 2.5. In this case slope of budget line is less than the slope of the indifference curve. In this case, what will then happen eventually, if I take this fourth one to explain it? So slope of budget line is flatter than the slope of the indifference curve. So let me draw this flatter one. So let us suppose this is our budget line, and what will be the indifference curve? It will be steeper. So let us suppose one is this, second one is this, third one is this, fourth one is this. So in this case, what happens? Consumer will consume 0 units of good x, sorry, y will be equal to 0 and all units of good y. So if y is equal to 0 in this equation, so x will be equal to 1000 upon 5, which is equal to 200. Okay, 200. That means consumer will consume 200 units of good x and 0 units of good y. Okay, so I explained all the possible corner solutions. And how do you write if you want to write it? In this case, let us suppose, so in exam we can write it like this. So we write first slope of indifference curve, which is equal to marginal rate of substitution between good x and y, and when we solve it, so it will be equal to marginal utility of good x upon marginal utility of good y, and it came out to be, in any of the case, let us suppose in this case it came out to be 2. Then we compare it with the slope of the budget line. Now slope of budget line is equal to the ratio price of x upon price of y, which is 5 upon 2, which is equal to 2.5. Then we say sinus slope of indifference curve is less than slope of budget line, so consumer will consume all units of good y, consumer consume 0 units of good x and all units of good y when we solve it. Okay, so it is up to you, but here I just want to give you an idea how to solve these kind of utility functions when we have 3 different cases. I hope I make myself clear in this video. Thank you.